Hello, and we're live, and welcome back. My name's John Stevenson. This is Clojure Study Group. Thanks for joining us. So last week we did a look at deploying our Clojure API application to the internet using Heroku. So we got that deployed live, and we also looked at writing some unit tests around that API as well, and looked at sort of ring mock to write some mocking unit tests as well. And so now we've got it online, and we started to test our API with writing a client. So I've written a little Clojure script application to be able to consume some of that. And then we found some interesting issues. Obviously, my website, my little website that I wrote to consume the API is on a different domain. So this is where we hit into this thing called cross-origin resource sharing, which is a security mechanism so that if you're trying to consume an API without any authentication, it's like a very basic security mechanism. So you can specify with cross-origin resource sharing exactly which domains can access your API, which is probably a simpler mechanism than setting up something like OAuth 2 or some other authentication approach as well. So I'm going to look at that. I haven't actually got it all working, unfortunately. I've got it working locally. So I've got two separate applications talking to each other, but for some reason it still's not working correctly on Heroku, unfortunately, but it gives me an opportunity to show you what the error is anyway. And we'll look at the actual website as well. We'll look a little bit at the threading macro, because I use that for the cross-origin resource sharing code. And we might look at a bit of the core async, although that kind of deserves a broadcast in itself. But let's see how we get. Okay, I'm going to share my screen. Boom, boom, boom. Sure. Oops. Okay, so let's go and look at the actual problem. So I've got the game scoreboard Swagger up and running. So this is a localhost one, and this is a Heroku one. And so it kind of works if you're using the game random score and you try it out, then it keeps on adding more and more random scores, and then it returns the overall scoreboard for you as well. So it's a simple way to get checking the API is working. And so we tried to do that in the, oops, that's quite big. Tried to do this in the global scoreboard in my little web app that I've written. And you can see in the red, we're getting some issues here about not being able to connect to, so ignore this one, but here we go. This one here. So access, so we've got this XML HTTP request, which is basically a request from this browser-based application. And it's talking to a Heroku one, and that might be interesting. I wonder if that's causing an issue. And it's from origin localhost 9500, and it's been blocked by this CORS, this cross-origin resource sharing policy. I got no access control. Header is present on the requested resource, which basically means it's not returning any results from the API, because it's not really, it's my requests from this website are not approved. So this is just it's just showing dummy data that I've hard coded into the application at the moment. It's not pulling anything back from the API because we've got this issue. And although I have kind of, it does look like I fixed it, because this is the results if I do it locally. Although it's I need to pick through this and actually pull out something meaningful, because I think this is just a JavaScript object, so I need to put it out into something more meaningful. But if we look at the results, I think if we scroll through all of this, we can find out so it's actually getting the UUIDs for the players, which is what it's returning here. So we are getting the information back. It's just not necessarily in a nice form that we want to. So we'll have a look at how I've done that so far, and then either this week or next week we'll make that into something that's useful on the UI side of things. We'll go through the UI, how we've built this as well. So let's go and look at the code. Any questions so far? Nope. Let's go and have a look at Spacemax. Okay, so the changes I've made, let's go and look at the changes I've made so far to the code. Let's go and look at the Git clients, look at the logs. So I've done a couple of things. I think I'd already done, so I already added the this kind of experiments in the REPL about playing around with the UUID. Yep, nothing to cover that. I think we covered that before. And a little fix I've just added was just to change the version of Leiningen that Heroku uses. For some reason, it's not being able to download 2.9.1, which is the latest version of Leiningen. I've seen error messages about the Leiningen version not being able to be updated. Oops. And so we're just going with the minimum version 2.83. What's doing that? What's it doing? And then there's this, so basically I'm going to go through this change here and talk about what we've done to add the cross-origin resource sharing. So I'll go through the code for that. So if you remember way back when, like 16, 17, video 16, 17, 18, we created this game scoreboard handler, which defines all our schemas. And we've got some game data, which is just empty at the moment. So if you just get the scoreboard, it will be empty. But if you get random UUI, then it's going to call and generate a random score with a random player ID and a random score between 0 and a lot. I'm not sure how big that is. 1, 2, 3, 4, 5, 6. Oh, a trillion. There we go. And but it's to add the cross-origin resource sharing. It was basically we have to add a wrapper around our application, really. So we're defining an API for our application, and it's got some Swagger information. So you can call this API, which was from the Composure API suite library. So it's an API function there that helps us define those APIs. And we've added this Ring middleware CORS to there. And we're specifically pulling in just the one function from that library. We don't need all of it. We just need the wrap cores, which is a piece of Ring middleware. Again, Composure API is all built on top of the very nice Ring library. And so there's quite a few different pieces of middleware that you can actually choose from. Have a look at that. So if you go to Practicalli Web Apps and middleware and Ring, so there's a whole bunch of middleware you can actually get hands on. So there's like classic ones we use is wrap reload, which will whenever you save changes, then it will reload all those changes that you've made in your code and reload them into the server, so you don't have to keep restarting your backend server. So your Jetty server doesn't need to be restarted. You can just inject a new version of your application code, and it will start running that. So you get the REPL experience in a backend server essentially. And there's a whole bunch of stuff. Other stuff. There's some interesting stack trace stuff if you want to do debugging. So there's a whole bunch of stuff that's really good for the development side of things, but also being able to pull out like different information from requests and responses as well. So you can apply middleware to the start of a to the start of a request. So when a request comes in, you can apply middleware to that, and then that basically is just a function or several functions that will basically take a request and they'll like pass on a request to either to the routes or to a handler. And also on the way back, you can have a middleware processing the response as well. So you might want to put some templating around every response. You might want to just make sure that there's some key information that's always in every response. You want to make sure that we're sending back appropriate data in the response. So there's lots of different ways you can, lots of different pieces of middleware you can use to do to shape the data. Because at the moment, once it comes in from the adapter, these requests and responses are just closure maps. So it's very easy to just have a function that is just changing and adapting and transforming the data in those maps. Okey-dokey. Any questions? No questions. No questions today. So that's so we've added this ring middleware. I'm going to make that a little bit bigger. And obviously, if you're just doing this, you'll need to also. Did I need to add anything to the project file? Let me just check. I don't think I did. Project files, project CLJ. So, oh yes, we did have to add ring cores as well. It's a separate library, and so we do need to add a dependency to the project.clj file. And we've also added this environ, which we'll come back to a little bit later as well. So just so add, oops, wrong button. So where do we get to? Oh yeah. So we've taken our so we had this def app defined already, which was using this API to define our API. We've got in each of our contexts, we've got a game, so we can have different games here, and each game can have its endpoints, its URLs that you go to be able to get different amounts of data. And we've got the random score here that we've been using, and this is basically just generating a random score and adding that to the scoreboard, and then the whole scoreboard result is returned, and we get our information, and that's returned as a JSON object. And in order to wrap cores, what we've done is added this threading macro here before the API. So we want to take the code that the API defines, and we're going to pass it through the wrap cores middleware. So we're going to pass all that information through this, and it will add some configuration to all of our requests, so that the server will allow access from every origin. And again, this is just a bit of a hack, really, because it's allowing everything. And obviously, in production applications, you shouldn't really just allow anybody to access your application, because that's kind of defeats the whole point of the security. And also, it makes it very easy for somebody to do like, either on purpose or accidentally a denial of service attack on your application, on your API. You can just basically call it millions and millions of times and either really slow down your service or just actually cost you lots of money if you've got auto scaling on or auto billing if you're not careful. And so we're at the moment we're adding it here, but you could just change this to your URL, so http domain.com. And so if requests were coming from myawesomedomain.com, then those would be allowed, and all the other requests would be rejected, and you get the error message that you saw earlier in the application that we wrote. And you can put some, it's recommended you put some headers in, so you need the origin, content type, and accept headers. I'm not quite sure about the X requested. There seems to be a bit of a lack of clarity exactly which headers you're actually required. So I'm going to have a look at that again. And then the types of methods that are allowed. So you could just limit it to just get requests. If you're doing posts, that's obviously very has a lot more potential for danger as well, because you're posting information. You could be posting some malicious scripts in there, so you might not want to put post in there. So you could just have a very simple get, a set of get APIs, and you just expose them very simply using this cross-origin resource sharing. And you would probably I would probably put some authentication around the post, or put something a bit stronger than this, just to make sure that people weren't like spoofing your domain or pretending to be your domain when they actually weren't. So this isn't a huge like safety mechanism, but if you're just doing gets, then it's basically just allows you to kind of manage the access very, very simply. So that's all I've done, and I haven't, unfortunately, it's still not quite working from the Heroku side of things. Let me go and show you what's going on in the client. Oops. So let's make it a little bit bigger. It's a little bit messy. It's still work in progress, but most of it is kind of fairly straightforward, I think. Let's go to the top. So this is just a simple Clojure script web application, and I created it with Figwheel main, which is kind of the new version of Figwheel. Some nice new features in there as well. It works quite nicely with the existing tooling, as well as the new Clojure command line tools as well. And it seems to be where most of the work is going around Figwheel as well. And it's pulling in some Google libraries to manipulate the Google DOM, so the document object model, and I'm using reagent here as well, and specifically using the Atom. So here is an interesting kind of way to require a library. So I'm requiring reagent.core. I'm giving it an alias, but then I'm specifically also including the Atom function. So I don't need to put in like the full domain, the full namespace name for Atom, and I don't need to use the alias for Atom either. I can just use Atom, and it will use the reagent one. This is quite useful because there's obviously an Atom for Clojure core as well. So you've got Atom, a definition of what the Atom function should do in two different libraries that are included in this project, Clojure core, which is included by default, and reagent.core, which I'm including specifically. So this Atom is going to take precedence over that. It's going to replace So the reagent atom is going to replace the clojure.core atom. And the main difference is that so reagent atom allows kind of changes to be watched, and it will update your components in your application. So if we kind of look at the web page, so this is the web page. It's just red for now. Whoops. And so this is just a very simple set of cards that show the game, the scoreboard, and if the underlying data changes in this, then these scores would actually change as well. And these are kind of components on my web app on my little web page. And I've added these. We'll come back to this in a moment. So it's kind of similar to other web applications we created before. So I'm not going to go through all of it. Essentially, I've got bits. Let's go to the clean bits. Where are we? Oh yes, I've been doing a lot of experiments. So basically, here's my web page components. So I've got a scoreboard. I've got an overall page, and we're just using the hiccup style to define our HTML. So we've got divs, and then we've got a section. So basically creating a header, and the header is going to have this this hero banner, which is this blue thing around the global scoreboard title. And then we've got the body, which is also a container, which has got the title and subtitle of. So these are just classes that we're using, so CSS classes, and we're actually pulling the content from the app state that we've got here as well. So if we look at the app state here, it's our local data model. We've got an atom, and it's got website title and website subtitle. So it's just we're just we're just coding into the components, into the application state, the information we're going to use in the components. And you can see we've also got a scoreboard here we're going to include. So we'll probably have the scoreboard. We'd have the scoreboard put into the app state eventually, and then be updated by functions that are calling the API endpoints. And it's this is really all the header of the page, which is up there. So all the things in blue, and the blue itself is the code. And you can see it's generating, if we go and look at the inspector. So this is just when you go into inspect, so it's basically the dev console. You can see all the elements around here. So you can see it's just created div, a hero body, and it's just basically generated the specific HTML code for us from our Clojure code. And this time I decided to use something called Bulma instead of Twitter Bootstrap. It's supposed to be a bit more lightweight, and you don't need to create rows. You can just create columns, so it's a little bit more simplified. And the names of the classes are kind of like, they're quite nice as well. So you can create a hero banner that is info, so that changes the color, and is bold, so everything inside that is bold as well. Actually, it creates that kind of shading effect when it's bold, I think. Yeah, so this is more of a solid color, and this is kind of fading in as well, so it's quite nice. And you got hero body, which is a container that's got the global scoreboard title in there and the subtitle as well. And I've just like with Twitter Bootstrap, I've just included that into the actual HTML page for this, and it's just using the CSS library from a content delivery network. So again, I don't need to download and manage that. I don't need to manage the version of that specifically. If I just need to increase it, I can just increase the value here if I get a new version. Yeah, it's pretty straightforward to include. You can look at the resources public index.html, and all it is just I've just included this style sheet link for style sheet, and then it's just the bull mapping. So it's exactly the same as we're doing that. It also encourages you to use Font Awesome for some of the things as well. I think some of their components uses Font Awesome, which again is just a graphical font for like icons and things like that. So it's quite interesting. Although it's Font Awesome is not great if you're caring about accessibility and accessibility readers for blind people, then Font Awesome is not great for that. So again, try and use that sparingly or not at all if you're doing anything that is reaching out to that audience. Okay, let's do that. There we go. And I've got the scoreboard and the scorecard. So the scoreboard is basically all the scorecards put together. So I'm going through here. I've got a little for loop that just goes through the player detail. So like it gets the player details out of the score map. If we go and look at the score map again. Oh, what did it do there? That's kind of strange. I don't know what I've done that. Oops, why is it? Why? My editor skills have left me for a second. Excuse me. Let's just open the file. Source. So, why is that not? There we go. Oh, yes. Oh, no, that's not the mode I want, is it? It's not the mode you're looking for. This is Clojure script mode. There we go. There we go. Right, we're back in there. I'm not sure what I did there, but obviously a feature I haven't managed to wrangle correctly with Spacemax yet. There we go. So where was I? Oh, yes. So I've got this for loop that basically is going to go through all the values in my data. Oops, where is it? There we go. Nope. Okay, data. So I've got this scoreboard source, which again, this is just dummy data until I get the API working correctly. And it's just basically giving us information in here. I can go in and add, if we're going to add an extra one. I've done this. Yeah. Very strange. It's gone. Oh dear. Live demo gone. I think got wrong. wrong. Okay, then we're back in track now. There we go. So I'm just going to add another one. Word. There we go. So I think if everything's still working, if I haven't broken everything, then we should be able to. Oh, there we go. You see, it's as I'm updating that code, then it's updating. It's updating in the UI straight away, and you keep on adding there as well. So ideally, yeah, we pull things from the API, and then they get updated in this website straight away. Okay, boom, boom, boom. And let's go down. A lot of tidying up to do in this code, which I'll do this weekend. And there we go. So we've got basically our three components here. We've got a scoreboard page, which loads in scoreboard with the scoreboard source that we've just seen. So that map we've just seen. And again, we would just change this to use the app state like we've done here, and we'll pull out the results of an API call. And so when we had a function somewhere in this code that updates that app state with new information from the scoreboard, then this scoreboard component would be redrawn with that new data. And this is why it's in the square brackets. This isn't a function call. This is basically a component that's managed by reagent. And we can see that down, another example of it as well. This is the reagent calling our application, calling our component. This is the one it's going to start with. This is our main component, which is the scoreboard page. And any components underneath that will be loaded in the first time we run the application, and then reagent manages those by watching the app state. And if anything changes in the app state, then those components will be redrawn. So it'll send the appropriate piece of HTML or data to the JavaScript engine that's running in your browser, and it would update the web page that you're looking at. So this is calling scoreboard this is managing scoreboard as a component, and the for loop is doing the same thing for scorecard, which is just a component that draws a specific card. So it's a style of box, and it's got a title and a subtitle at the moment, and it seems to be the closest one to what I wanted from Bulma. Card, yeah. So you can get a card. Did I do a card? Oh, box. Sorry, box. Oh no, it's not that one. Okay. But there's a whole bunch of components here. I'm not quite sure. Maybe there's an element. There we go. Oh yeah, box. Yeah, so this is just a box. You can do also, it gives you options of what you can add in there as well. So it's quite straightforward to go and just have a look at the code that it's using, and we can just convert that into yeah, we just type this up into Hiccup syntax as well. So it's kind of nice and easy to manipulate with Clojure. So the for loop is basically saying that we're going to take the score map, which is essentially, So we've got this scoreboard source, which is our map of players. So this is our local copy, our test copy of the what we hope to get from the API, and it passes that in, so that becomes score map. I probably should have called these the same. It would have been a little bit easier. And it's basically creating a section here so that the scoreboard is just one particular section, and it's gonna loop around the score map, so the actual scoreboard source, and for each element, so for each map in there, because this score map is a vector of maps, as we've seen before. Let's just pull that out. Yeah. Undo. Something very strange has gone on with my undo. What? Let me just slip that in there. There we go. Go down to where I was going. Where was I? There we go. Yeah. Just put that in there for a second. Just come out. So we've got the score map, which is this vector of maps, and the when we go through the for loop, it's going to take each of the elements from the vector. So it's going to take this map, and that's going to be the first player details, which it is player details as well, and then that's going to pass that map there to scorecard, and then that will take that argument of score details. So it pulls in score details, it extracts the player name. So it's a player name, so it'll pull out Rachel Riot, and it'll make that a class of title, and it'll do the same thing for subtitle for the score. But we might want to, I haven't quite decided whether want the player name or the score as the title. We shall see. I guess you want to see your name quite big with there as well. So that's how that's working. So it's basically, so it doesn't matter how many scores we've got in the scoreboard. We'll just loop through all of them using this, iterate through all of them using this for loop or this for command. And we can also put in some conditions in there, so we could limit how many scores we want to display. So I can do like a when clause to see if it's full. If we only want to display the top 10, we could put in a condition in here to say, well, just show us the first 10 scores. That would be it. And I guess ideally to have a nice UI, you would have just some pagination. So you just have like paging through the number of scores. And we could have like some options on the UI to just basically select a particular player and just see all the players' top scores, or the most recent top scores as well. So you can play around with that quite easily. Let me just delete that. Oops. There we go. And so that's basically how this website works so far. And then what I'm adding is, so I've added cljs-http client. So this is a library that acts as a HTTP client, and we're just giving it an alias of HTTP. And so this will allow us to go and sort of do a GET request or a POST request to our API. And it it kind of recommends you get those requests as something called a core async channel. So it's basically like a queue. So it allows you to like basically call, do all these gets, and it puts all the results onto a queue, and then you can manage the queue in different kind of code. So you can have something that just pulls the code off and puts and updates the application state once you get the results back from the API, and it allows you to basically, as it suggests, it's asynchronous. So it allows you to basically do something and then just get on with something else. So you don't have to wait for the API to respond if the API is busy, or if it's just a very slow API, or you've just got a very slow network. Then you can still do things with your user interface or your application while it's going off and doing this thing in the background. Any questions yet? And where we go. So I've got this working locally. So let's just see. I just commented out some of the things. So I've got yeah, API data section. Here we go. So I've defined some endpoints just to help me not have to type in URLs all the time. So I'd put in here all of the web addresses, and I'm just getting these from, actually the easiest way to do is get these from the Swagger user interface. So you can go in here, and each of these, oops, whenever you're like trying these out, if you're doing like the get things here, it's giving you a curl command if you want to test it on the command line, and it's also doing a request URL as well. So this is what you would put into the browser to be able to get the random score. So if we do that, boom, then it's just going to give us, oh yes, it might take a few seconds to warm up, but if you don't use this for half an hour or an hour or something, then it needs to start and warm up. So it might take a second, just come back to that. But I can use this in my code as well. So yeah, so here I've just got the local host that's running the game, so the game API, and here I've got the random score for that's deployed on Heroku. And yeah, and then I'll just add the different scores on here. You're still thinking about it. So for each of these, so I'd add player accounts, new player, and so on to that, just so it can have a simple way to list all the endpoints. And although we can also, thinking about this, we can also pull down the swagger.json file, which is, we go back to the API project, and we just go up a little bit. So we do have the spec, we do have this Swagger JSON spec, so we could actually even just request that and pass that, and then we wouldn't need to hard code, we wouldn't need to worry about changes to getting the changes to the application. We could just pass swagger.json and get all the API descriptions from there. That might be quite a nice way to do that. So that's something for another broadcast, I think. But each of these has, yeah, each of these will, once you try them out, then they'll have the request URL that you can send to as well. There we go. Oh, there we go. Cool. Did that ever work? Oh, yes, it did, yes. Yeah, so you can put these into your browser, and you just get them back. And once your application's warmed up on Heroku, then it's obviously very fast. It's just the first time. After a while, it will basically just decommission your container, and so you basically just have to. It basically rebuilds it and starts serving the request if you waited for a certain period of time. Obviously, that only does it in development, and that's because it's free. If you're doing it in production, then it doesn't do that at all. Let's pull it off. And what else we? Oh yes, so that's that one. So that's the. Let's go back to our UI. So we've got some endpoints defined, and then this is just a function, a helper function we've got here to get the details from the API. And all this is doing is just basically getting, putting information on the console log. So that's the, as we saw earlier, we go back to the browser and go back to the application there. And if we're going back to inspect, then if we go to console, then that's what it means by the console log. And we did see earlier on, so it is putting out some information in here, so you can kind of see a kind of log of what's going on in the application. You can see errors in there as well. And the object. Oh, there you go. Is that the object? I think this is what the this is one of the things. So this is just a as it says, it's an object, which is like a JavaScript object, and so it's got all the kind of like serialization stuff. So we need to unpack that and explore what the contents is, so we can pull out the most useful information from there. But that's the console log, and so if we go back to here, and we've got this connected, so we're running this application through our editor. So we've got a REPL running. So we've got this REPL running, and let's and so if we so we've got this function defined. Basically, it's going off. It's going to do a HTTP GET. So that's using the HTTP cljs library. And it's going to use the endpoints, which we're pulling from. It's going to be one of these. And then one of the things I was trying to do to make it work was add this extra credentials, so like to just not use credentials, because we haven't got any security essentially set up apart from the CORS, which is already there. And what we're doing is just returning whatever the body of the response is, and we're just pushing that into the console log. So we're not doing anything fancy just yet. And so we're calling the get API function, and then this is just basically getting the particular endpoint. So this is the same as doing it's basically the same as doing this HTTP get random score, essentially. And so is this going to do anything interesting? So if we evaluate this, and so this is putting something onto the channel, onto the core async channel. So this is basically means the result of this HTTP get for that particular endpoint is going to push it onto a channel, and that's going to be our response. And then from that response, we can pull out the body of our JSON object, and then we're just writing that to the console log. And there we go. And you can see we've got this information here, so, right down the bottom. And I believe, so this is some data structure we need to explore and pull out the right information from. So I think we need to convert this from like JavaScript into ClojureScript. So there's a function to do that. And where is it? It's not that one. Oops. Where's it gone? No, it's not in there. Root. I've lost it now. Oh yeah, there we go. So it's got, so this is the UUID that's pulling back from there, because that's what the API is serving up. And that's the, is that the score? Yeah, and that's the score that it's returning. quite sure what that is. Yeah. So it's we need to pull it out. I haven't quite got this worked out yet. I need to do some. So there's a cljs thing which converts JavaScript into Clojure scripts, but I think I just need to pass some JSON object as well. So there's probably a JSON. Is there a JavaScript JSON thing there? So the JavaScript cljs. Let's just have a quick look at that. There's quite a few things there. Is it going to pop up my? Oh, there we go. So yeah, so it'll traverse a JavaScript array and turn it into ClojureScript vectors and JavaScript objects into ClojureScript maps. Okie dokie. So that's what I tried to do. Although I think I need to do something else. I need to check my core async code again to figure out how to do that, because it's still getting the result from there. So it's getting an object from the channel, many to channel. But when we look at that, oh, that's blocking the Heroku one. Sorry. Let's do that. On there. So JS to CLJS, there we go. And then let's slurp this in there so we can wrap it around. And let's see what we get when we just evaluate that function. Anything to there? Yeah, we're still getting. Yeah, so we might need to do something else to pull that information out, because it's still. I'm not sure if it's just the way it's passing it to console log, or if we need to do something else to it. Let's see. Let's try just try the print line. And that's the whole thing. Just a guess. I should really go and have a look at. Oops, I don't want to do that. Go and have a look at what we should be doing. Print it. So, oh yeah, so that's basically just printing out the object. Oops, why is that not working? There we go. Oh yeah, so that's getting so is that getting the channel? So we're probably not reading from the channel properly. Okay. So that's something to go and have a look at. But essentially, that's what we need to do. We'll get this HTTP endpoint. And at the moment, I'm just getting the local one because that's the one that works. I'll try and fix the Heroku one. That might be something blocking, or I might need to send some request. But the request should be, the request with the origin is getting sent. It's just something is blocking it. So I'll need to do some more Googling around that. And the next time we'll have a look at, I think I've got this already. Yeah, I've got the, I've got a core async. Yeah, I've got core async example here. So I'm going to go through this and see what we need to do. Oh, I might need to take this. I need to take the value from there and do something with it. So you can take the value and actually put that into a swap and update the application state. So I'll go through this in more detail next time, and I'll come up with a nice little example to go through some core async. It is really useful. And so basically, you're just creating a channel, and you can set up a listener to the channel, so a listener to the core, to the queue of a piece of information. You can put any Clojure information onto the queue you want to, onto this channel. and you can have a listener, so it's just going to listen to the channel and then print when it's got a value, and then also the value itself. And then you put things on that channel, and the take will then show it off. So you can do things, you can make this code work only when something else puts something onto the channel. So this is why it's asynchronous. It will happen at a different time to when another action happens. So we'll go through that. Yeah, I think we'll go through that next week, actually. It'll be a good chance to go through core racing. And we'll go through that, and then we'll apply that to the website that we're building there, and use that to pull out the information from the channel and put it into the app state, and then that will update my application. And we should have a website that consumes my API, at least locally anyway. Any questions around that? Nope. I'm going to write all this up and make it a lot more clearer. It's a bit more of an adventure because it's been a while since I've done all this stuff. So hopefully finding that useful. And I will see you next week. Thank you very much, and goodbye. There we go. Oh.